Bhuneshwar sir, shall we start?
Yes, sir, you can continue.
Okay, sir, wait, I will share my screen. I hope screen is visible.
Yes, sir.
Okay, so we'll continue. So, dear students, welcome to all of you in this today's session. I hope all of you have completed all these five parts: main fuselage, top fuselage, tail fin 2, and tail plane. Be ready with your next part. So, once again, I'll just welcome to all of you. Welcome to our Wings of Hero. We'll continue our session. It's already 6 p.m. Yeah. So we have done with the tail plane. Now directly, without any discussion, let's jump to part 6a. That is main rotor. So here we can observe what we have: our helicopter. This is our main rotor. Okay. I mean like main blade and tail blade, and here to fix this main blade and tail blade we have the mechanical device. Okay, this one. This one and this one. Okay, so these two components what we have, that is our rotor. Okay, then we'll go for propeller. So part 6, that is our main rotor and tail rotor. Okay, yes, so here we have all geometrical parameters of main rotor. Okay, this one. After this we'll go for tail rotor. Okay, then we'll come for propeller, main propeller and tail propeller. Okay, yes. So here to deal with this main rotor, of course we have to go to open VSP, run the software, and select fuselage and add. Why we have to select fuselage? Because fuselage is like circular geometry. Okay, and here we are looking to design circular kind of geometry itself, that is our rotor. Okay, main and tail one. That's why it's better to select fuselage geometry. Okay, and that is what we have selected the fuselage, and we have added. As soon as we add, we'll get the default fuselage, and now we have to just give overall length of our rotor 1.35 meter. Okay, this length from here to here, overall length of this rotor is 1.35, like this. Okay, so come to design, give overall length 1.35, sorry, okay, 1.35 enter. That is our overall length. Okay, and after that you have to come to each and every cross section. You have to fix each and every cross section at some distance, and then we have to change the cross section type. Okay, so default we have 4 number of cross sections. Okay, let it be 4 number of cross sections. Now we will come to first cross section. First cross section length 0.33750 meter away. Okay, so yes, already default we have 0.3375 itself. Okay, now we will jump to second cross section. Second cross section same, right? And third cross section 1.0125. Okay, third cross section 1.0125, and fourth cross section 1.350 meter away. So fourth cross section 1.35. Okay, that is our overall length. So which means default whatever we have, okay, the value let it be. Now just come to each and every cross section, change the cross section type. Zeroth cross section type, of course, the pointed type. It's already pointed type. Now we will jump to first cross section. Cross section type, that is circular type of cross section, diameter 0.5 meter. So jump to first cross section, type of cross section, circle type of cross section, which is having a diameter 0.5 meter. So just type 0.5 enter. Next, second cross section, type of cross section same, circle type. Okay, all cross section of this first, second and third cross section type, it is circle type of cross section, which is having a diameter 0.5 meter. Okay, so we will just directly give 0.5 meter. Okay, we will choose the cross section type, circle type of cross section, and the diameter 0.5 meter enter. Same for third cross section, the type of cross section, circle type of cross section, which is having a diameter 0.5 meter enter. Okay, done. Of course the fourth one will be pointed type because we have to close the geometry, and that is what mentioned here. Okay, so which means we have done with our main rotor. Okay, so let's check the view, share this one, and here we have top view, fit on screen, and we have all 4 views. This is our ISO view, top view, okay, front view and side view, all views we have. Just go to file, use save as option. So I'll just copy the directory. Okay, I'll just paste, yeah, I will give the part name, part 6A. I will call 6A. Why 6A? Because as I told, this is our rotor. Okay, so part A we will call main rotor, and part B we will call the tail rotor. Okay, so that's why just type 6A, that is our main rotor. Enter or accept. Yes, so let's open once again. Okay, so we'll go to new. It did not got saved, so no problem. You just quickly just into the parameters. 1.35. We'll come to section. We'll come to cross section 0.5. Enter. Second, same circle type 0.5. Enter. Third one, same circle type 0.5 meter. Enter and close. Yes, so we have done with this. Let's go to file. Save as option. Now once again I'll just do part name part 6A min accept. Okay, so it got saved. Now we'll just go to file and new. Why new? Because now we have to deal with next part, that is backside rotor or tail rotor. 6B, this one. Okay, so from here to here, length, okay, that is 0.5 meter. So we have to add fuselage. Okay, with the help of this geometrical browser. Okay, I mean, like, with the help of this geometry, fuselage geometry, easily we can complete our part 6B, that is tail rotor or back rotor, this portion. Okay, this one. So here we have mentioned overall rotor length 0.5 meter. So just type length 0.5 meter. Enter. Okay, come to each and every cross section. So here we have cross sections. First cross section, second, third, fourth, same. Okay, so first cross section 0.1250 meter away, 0.125 meter away. Second cross section 0.25. Okay, so default we are getting the same uh, distance of each and every cross section, so let it be. Okay, why we are getting same? Because here we have given overall length, no? And default we want 4 number of cross sections, and defaultly we have 4 number of cross sections, so automatically each and every cross section it got adjusted. Okay, the only thing what we have to do, we have to come to each and every cross section and we have to change the cross section type. That's it, what we have done for previous model. Okay, it is our tail. Okay, main rotor. So we have to do for this tail rotor, same procedure you have to follow. Okay, the type of cross section, pointed type of cross section. First cross section type circle type of cross section. Okay, first, second and third, the type of cross section we have to choose circle type of cross section and we have to give same diameter. Okay, that is 0.2 meter. So first cross section, the type of cross section, circle type of cross section, which is having a diameter 0.2 meter. Enter. Okay, second cross section, same circle type of cross section having diameter 0.2 meter, enter. Third cross section, same circle type of cross section which is having diameter 0.2 meter, enter. Okay, and fourth one, yes, it's a pointed type of cross section, so automatically default we have same the type of cross section, pointed type of cross section. Okay, so we have done with the tail back rotor or back rotor or tail rotor. Okay, so we have done with this component. Okay, so we'll just share this one, and here we have ISO view, left ISO view, and here we have all the four views. Okay, and that is what it is showing. So we'll just change the window 4 to 1, and we'll go to file, use save as option. This is our part 6a, sorry 6b. Except. Okay, so we have done with main rotor, backside rotor. Now next we will jump to propeller. Okay, first we'll go for main propeller, then we'll create the tail propeller. So here we'll just analyze our real model what we have here. You can observe clearly, totally we have to design 3 blades. Okay, 1 2 3, and you have to arrange in such a manner, I mean like you have to create in such a manner it should look like this only. Okay, so we'll just continue. Yes, main propeller. Okay, so here you can observe we have to use 3 number of blades, 1 2 3. Okay, all the parameters it is mentioned here, given data, diameter. Okay, overall diameter from the center point to the tip of the blade. Okay, tip of each and every blade, the overall diameter is 10.69 meter. Okay, this one, overall diameter 10.69. Okay, of this blade. Now we will just come to open VSP, go to file, new. Okay, come to geometrical browser, select prop. So here we have prop, that is our propeller. Select and add. We know as soon as we add Here in this VSP window, we'll get the propeller geometry. Okay, that is our inbuilt default propeller, which we got from OpenVSP software itself. Okay, we'll just fit on screen. Okay, so default we have three number of propeller. Of course, we also want three number of propellers. Okay, three blades. Okay, so here we have three blades. Let it be, no need to do any changes. Okay, number of blades we will maintain same three. We have to change the diameter. Now currently the diameter is 30. Okay, so instead of 30, now how much we have to give the diameter? That is 10.69 meter. So we will use this data what we have, 10.69, enter. Okay, yes. Okay, and number of blades, okay, already we have total number of blades 3. Let me change the view. Okay, we'll use 4 window. This one I'll keep top view, and this one front view, and this one left view. This one, let it be the ISO view. Okay, so we can observe our model from each and every view. Okay, yes. So now we will give next parameter, rotation angle, 31.30 degree. Okay, rotation angle in the sense, okay, from here to here. Okay, suppose this is your center point. Okay, from here to here, this angle. Okay, this angle and this angle, it is mentioned 31.30 degree. So we just give the rotation angle 31.30 degree. Enter. Now next parameter, beta 25.36082. 25.36082. Enter. Okay, and root cap flat type. Okay, so here we have to come to blade. Okay, so what we have to do now? Yeah, we will change the root cap and tip cap. Okay, this is our root cap and tip cap. So we'll change root cap and tip cap of our blade. Let me use these values first. Cross section radius we will use. Okay, so we'll use this blade control points. Okay, then we'll go for this two parameter. Okay, because here we have blade control points. Okay, so we will give the input values. We have 0.07 blade control point, 0.07. So So we will use 0.07. Enter. Okay. This for this also 0.07. Enter. Because currently the shape it's like this. Okay. So we don't want that shape. Instead of that, what we have to do? We have to do changes. Okay. Like our blade, what we have, it is like a rectangular shape like this, right? Okay. Root side you can do alterations, but from here to, let me go to view, 3D view. Okay. You can observe from here to here. Okay, it's like a rectangular shape. So that's why we have to maintain same control points. Okay. So I'll just type 0.07 control point, in the sense this 1 2 3 4 5 6, what we have, all these control points. Okay. 0.07. Enter. You can observe geometry. Oh, sorry. 0.07. Enter. Okay. You can observe the shape of this blade. It will change. Same for this also. 0.07. Enter. 0.07. Enter. This one also 0.07. Enter. And this one also same, 0.07. Enter. This one also same, 0.07. Enter. Okay. Yes. So we have done with control points. Okay. And our blade shape, it got changed. Initially it was not like this, right? So that is the use of this control point tab, what we have. Now next, what we have to do? Okay. So now we will come back to the parameters what we have. Okay. 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 So now we'll just change this cross section type to circle. Okay. And we'll jump to first cross section. The type of cross section, it's 16 series. So we'll go with okay. Yeah, we'll go with the parameters what we have. Okay. Here. So instead of the aerofoil, we'll just use this parameter. First cross section 0.11527. Okay. 0.11527. 7, enter, and this one 0.61614, enter. Second cross section. Okay, so we'll select second cross section type 4 series. Just wait, it is taking time. Usually when you deal with the propeller, no, okay, because of the large parameters what we have, okay, like this, you'll get a problem. Okay, software, it will get hang. Well, that is what it happened now. I have to close this program, that is open VSP. Just 2 minutes, I will restart once again. Yeah. Sorry for the inconvenience. We'll just add once again and quickly will give values. Okay, propeller. So we'll come to design. We know overall diameter 10.69. Enter. Number of blade 3. Okay, each and every control point 0.07. Just copy this one. Control C. Control V. Enter. This one also Control V. Enter. Control V. Enter. You can observe shape of this curve, it is changing because of same control points. Okay, yeah. So I'll just save this file because again, if we get the same problem, then at least we'll be having the backup file. Okay, I'll just save this one. So we'll call this one as part 7. This is our main propeller. Except, okay, yeah. Okay. Okay. Yeah. So now what we'll do? We'll come to cross section once again. Okay. As I told, zeroth cross section. Okay. Circle type of cross section. Radius 0.03506. Enter. This one 0.18. Okay, let it be. It's same. Next, first cross section. Okay. Yeah. Radius 0.11527. Enter. And Of course, next one you will get automatically. Okay, so you should know one parameter, that's enough, which means you should calculate one parameter. Second cross section radius 0.650. Second cross section type 4 series. Just wait, it is taking time. Yeah, now it's working. Okay.
Sir, I
Just
think we need to add another cross section.
come again.
I think we need to add another cross section, sir. They have given another radius.
Yeah, that is what. Just wait, it's working slowly. Yeah. So currently here we have two number of cross sections only, right? So that's why. So we will add one more cross section. Mm, if it is working in your laptop speedily, then you just go with this parameter. Okay, it's a little bit slow in my system. Let me check. Mm, yeah, 1, 2. Wait, I'll just insert one more. Okay, so all of you just add one more cross section. Okay, first cross section radius you give this to give any one parameter. Okay, this one, and for second cross section this one, and last one radius 1. Okay, and see, by the way, we have given overall diameter 10.69. Okay, so if you want to insert, you can insert, otherwise just round up to 2, that is also acceptable, no problem with that. Okay, 1, 2. Yeah, now we got. So we'll just come to second cross section. We will change the cross section type 4 series. Okay, now we will give our parameter radius 0.65. Okay, 0.65. Enter. 0.650. Okay, and that side automatically you'll get this value Next, third cross section. Okay, so defaultly you will get 1 and 5.345. Why you will get same? Because here we have given overall diameter, no? That's why. Okay, so 10.69, half of that, and that will be 5 point this one. Okay, yeah, so we have done with this. Now if you want to modify, you can modify. So before that, let me save this one, otherwise again we lose our geometry. Okay, yes, so now you can modify, that is your leading edge cap type, whether you want to keep flatted type, okay, or rounded type, or edge or sharp. You can change the leading edge cap. Okay, uh, here. Okay, similarly root chord, okay, root cap, tip cap, like that you can modify. I'll just maintain the same. Okay, flatted type itself. Okay, here also if you want to do some modifications with respect to the angle, okay, axial offset with respect to the radius, okay, and root cap type, it's flatted type, so we'll go with the flat type, root cap type, and tip cap type, rounded. So tip cap type, rounded. So default we have same. Now just go to file and save. We have done with our main propeller. Okay, this is done. So we'll just share this one. Yeah, so here we have one window, and this is our left ISO. Here we have top view, front view, and left view. This is our ISO view. Okay, yeah, so I just change the name. Instead of propeller geometry, I will call this as main propeller. Okay, yes, enter. Once again I will save this one. Yes, okay, so we have done with this now. Next we'll go for tail propeller. Okay, so if you want to change the camber location and some parameter, you can do that also. Okay, so ensure that parameter which you are using, that is very important. Okay, whether you are using radius or this one, so better go with the radius, because this is a circular disc, no? I mean, like the object what we have, the geometry, okay, from center point we'll get shape like this, circle type, right? So that's why go with the parameter, that is radius or diameter. Okay, and you can change the design type, propeller mode. Okay, if you want blade and disc, you can use both option. Okay, so you can able to see the blade and disc. If you want only disc, then use disc. So we want blades, that's it. So that's why I'll just click the propeller mode, that is blades. Okay, so I'll just say once again. Why I'm telling, because you should know all these options. Okay, if you are dealing with a propeller, okay, that may be for other aircraft, not only for this one. Okay, of course you will be getting project, so or you will be trying some other aircraft from your side, so you should know how to use all these options. Okay, according to your convenient or for your model. Okay, now let me confirm once again. Yes, part 7, main propeller. Okay, so we have saved this one. Go to file and new. Why new? Because now we have to deal with tail propeller. Okay, so here also we know the given data, diameter of this propeller 1.86 meter. So just come to geometrical browser, select propeller, and so we have default propeller. Overall diameter 1.86 meter. Come to design, give the diameter of your propeller 1.86 meter. Enter. Use view and fit on screen. Number of blades, of course, 3. Okay, here we have 2. So I just suggest to go with 3, or else even you can reduce to 2. No worry with that. Okay, like this. So main propeller also having 3 blades, no, and we'll maintain 3 blades for tail propeller also. Okay. Okay. So no worries, we'll go with 3. Later you can change the number of blades. No worry with that. Okay. I'll just type 3. Okay. Now after this, we will use our other parameters. Okay, rotation angle 20.721. You just use the view. This one I'll keep in top view. This one front view, and this one our left view, and this one is a view. Okay. Yes. So we have rotation angle 20.72165 degree. Rotation angle 21 point. Just wait, it is taking time. 20.7. 20.72165. Enter. Okay, and beta angle 20 degree. So default we have 20 degree. Let it be. We will come to blade control point. Okay, we'll use 0.27. So here we have blade option. Okay, in this tab we can change the control points. Okay, so we have totally 9 control points. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can maintain same control points. Why we have to maintain same? Because we can observe this one also is like this only. Okay, so we'll go with 0.0, sorry, 0.27. Enter. Just copy this one, Control C, and use Control V to paste. Enter. This one also Control V. Enter. This one also same, Control V. Enter. Control V, enter. You can observe the shape of this blade. Okay, not only for one blade, all three blades shape is changing because I am changing each and every control point. Each and every control point, in the sense, each and every cross section what we have here. Okay, in this complete blade. Okay, if I just consider one blade, in this one blade, okay, we have number of cross sections: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so each and every cross section control points you can change. Okay, and you can maintain same to get the rectangular shape, or else you can vary. Now currently we have to maintain same because the shape is like a rectangle type, so that's why we are maintaining 0.27. Okay, same control points. Control V, enter. Control V, enter. You can type here, or else you can use this all the control points what we have. Okay, like this you can change. Okay, you just select and take your control points to that level and fix. That's it. It's better to type because it will take time to update. So control V, enter. Okay, so all these control points automatically it got set to 0.27. Okay, root chord to radius ratio. Okay, so here we have radius and outer radius, that is r by r. So that's why while discussing about this propeller, I told you that what parameters we have for this propeller design. Okay, we must know with all those parameters, then only it is very easy to design propeller. Now we'll come to the cross section. Okay, we have default, we have one and two cross sections. Okay, so we want three cross section. Okay, so we'll just insert here one extra cross section. Now once again I'll just check 1, 2 and 3. Okay, yeah. So before I give my values, what we have here, let's save this one, otherwise simply we lose our geometry. Use save as option and call this one as part 8 tail propeller. Enter or accept. Yes, so we'll come to first cross section. Yeah, we'll change the zeroth cross section type. We'll just use circle type of cross section. Okay, so automatically you will get the diameter. Okay, so let it be, because here you have given overall diameter, no? So that's why let it be. Now just come to first cross section. Okay, this first cross section type, it's 16 series, so you can select circle or you can maintain 4 series, no problem, but you should use the parameter. Okay, so I just prefer use circle itself. Okay, or else go with the 4 series. Okay, it will affect when you give your radius. That's it. Okay, so here we know first cross section radius 0.450. 0.450, enter. That is our first cross section radius. Second cross section radius 0.70. 0.70. Third one, of course, it will just impact, okay, 1 and 0.30. Why? Because here we have one overall diameter. Okay, yeah. So we have done with the tail propeller. Let's change the window 4 to 1. Okay. And if you want to change the blade number of blades, just type 2 and enter. That's it. Okay. If you want to increase the diameter, still you can increase like this. No worry with that. Okay. So it's a small tail propeller. Okay, you can observe tail propeller is small. Okay, the overall diameter is small as compared to the main propeller. So you just go with 1.86 meter. Okay, 1.86 enter, and we'll go with 3. Yeah. So we'll just save this one. Go to file, save. Okay, we have already saved. Tail propeller 7.1. Okay, yeah. So we have done with main propeller, tail propeller, and next the last part we have to do landing skid. So it will take just few minutes, no problem. We have to deal with the 3 landing skids. Okay, this one, and this one. Okay, this one, and this one. 2 horizontal, 2 vertical, and one more to fix. So what we'll do, we'll call the landing skid in 3 way. Okay, let me show you 3D view. Okay, this is the best figure now. So you can observe here. Okay, the landing skid what we have. Okay, if we design first one, second one, and third one, that's enough. Okay, uh, we can have a symmetry, right? So for this complete landing skid, we'll split this complete landing skid in 3 way. Okay, we'll call this one as our first landing skid. Okay, landing skid A, landing skid B, and landing skid C. Okay, then once we complete each and every landing skid separately, then we'll just use symmetry option. Okay, just to show this side also. Okay, now currently we can able to see left side. Okay, and after symmetry we can able to get the right side, and that is what it is shown here. Okay, this one. Okay, we'll complete that part tomorrow, and we'll just go for assembly. Now I'll just stop the session. I'll go for question answer session. So the time up, we will stop the session. Yes, students, if you have any questions so far, whatever you have discussed in today's session, you can unmute, or else you can use chat window. If no question, then just update on a chat window. No, so that will be confirmation for us to wind up the session. Okay. Tika telling no, sir. Netra. Okay, Netra, she's asking something. Let me read her query. Sir, how can we know it's 4 series or 16 series in Propeller? You can come to blade, oh sorry, this section. Okay, each and every section, what you have maintained. Okay, I mean like which type of cross section you have maintained, you can have a preview. Okay, see, now currently I am on third cross section. Okay, and third cross section, type of cross section which I have maintained, that is what preview here we can able to see by clicking on the show option. Okay, now see, I will change this 16 series to circle. Okay, and once again I will click on show. See, uh, suddenly the cross section type got changed, right? Why it got changed? Because I have chosen the cross section type circle type. Okay, and if I change this to ellipse and if I enter, see, automatically the type of cross section also will get changed. Similarly, I will do for second cross section. Okay, so currently it's 16 series type of cross section. I will change this to circle, ellipse, or just let's select a rounded rectangular type. Okay, see. Particularly at this point, okay, you can observe from here to here it's a aerofoil shape, but second cross section type, it got changed. It's a rectangular type, rounded rectangular type. Okay, here this side is rounded and the shape is rectangular shape, so that's why the type of cross section is rounded rectangular type, because here we have chosen the type of cross section rounded rectangular type of cross section. Okay, and again you can alter and you can have a preview. Okay, that is the answer of your query, Dikshita. Oh sorry, Netra, I hope you understood, Netra.
Yes,
And
sir. Thank you, sir.
yes, and Dikshita is asking how to change a rotor cap and tip cap. Yes, very good. So here we have to come to modification. Okay, you can change the cap type flat to round. It's this one is already saved. No, I'll just go to new, because I don't want to disturb that component, because tomorrow we have to do assembly. So I'll just add the propeller. Okay, here we have default propeller. I'll just fit on screen. See, now currently uh, here leading edge, it's a flat. You can change this to rounded type. Okay, and you can give the length. Okay, and also you can come to more option. Okay, you can change root cap type. Okay, root cap type flat to round. See, root cap type, it got changed flat to round. You can observe now. Okay, this is our root chord, right? Okay, and root cap type, it's rounded type. Now if you want to change round to flat, you can click that flat option. Okay, automatically it will get impact. I mean like that type of cross section, it will get impact to your geometry. Okay, especially at a root side, because you are playing with the root cap type. Okay, if you want to go with edge type of root cap type, just select edge type. See, it's edge type. Yeah. And if you want to go with sharp, you can click on sharp. See, okay, now I just want to maintain rounded type. Okay, it got impact here. And similarly, you can change your tip cap type. Okay, here this one, just rotate this one. Okay, or else use 4 window option to observe your model clearly. Okay, this is our tip portion. Okay, and here we have tip cap type. It's rounded type. We can change this to flat. See, it got changed. Okay, and edge, like this you can do changes. Dikshita, I hope you understood. Yes, yes, okay. Any other queries, any other questions? Just type no if no questions, so that we'll end the session and we'll continue tomorrow. Okay, no. Okay, 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 okay. Yes, yes, thank you to all of you for joining. Okay, sir, we'll just end this session. Bhuvaneshwar sir.
Yes, sir. Thank you.
Okay, okay, thank you. So students,